Before we move on, let's review some basics about probabilities. The first rule we're going to look at is the addition rule. So the addition rule states that the probability of getting event A or event B, which also can be written as the probability of A in union with B. Note that this symbol here, which looks like a U, is actually means union. We can say that that is actually equal to the probability of A occurring plus the probability of B occurring minus the probability of A and B occurring together. But if event A and B are mutually exclusive, which means that they cannot occur together, then the probability of A and B occurring together is 0. So in cases of events being mutually exclusive, the probability of A or B occurring is the probability of A plus the probability of B. As an example, let's take a look at a one locus two allele system in a population of beetles. And we want to know what is the probability of choosing the capital A allele or the lowercase a allele in this little population of beetles that we have here. Applying the addition rule and assuming they can't occur together, then it's the probability of A plus the probability, big A plus the probability of little a, which in this case is the frequency of big A plus the frequency of little a. So in this case we have 4 big alleles, and we can count them 1, 2, 3, 4, over a total of 10 alleles in this example. We've got 2 in each individual beetle. And the frequency of the little a allele is 1, 2, 3, 4, 5, 6 of the 10. And if we add those together, we get 10 out of 10. And of course, that's 100%. So the probability of choosing big A or little a in this population is obviously 100% because those are the only 2 options. The probability of just choosing big A is 4 out of 10, which equals 0.4 or 40%. The probability of choosing little a is 6 over 10, which is equal to 0.6 or 60%. The second rule that we will look at is the multiplication rule. So if A and B are independent events, which means that one does not depend on the other, the multiplication rule states that the probability of getting event A and event B, which can also be written as the probability at the intersection of B, this symbol here is a mathematical symbol just meaning and, that is equal to the probability of A occurring multiplied by the probability of B occurring. So as an example, let's look at the one locus two allele system in our population of beetles. And we want to know what is the probability of the big A genotype in this population. So we can look at the frequency of choosing the big A times the frequency of choosing the big A. So we apply the multiplication rule, and assuming they are independent events, and in most cases we'd have a really large population, and we're just using a small population here to make the math easier, then the probability of a big A genotype is the probability of A times the probability of A, which in this case is 0.4 times 0.4, which equals 0.16, which equals 16%. We can also ask the question, what is the probability of the big A little a genotype? And in this case, there's 2 ways to get this genotype. We can have big A little a, or the reverse is true, we can have little a big A. So we need to multiply the probability of big A little a times 2 to get the real frequency here. So we have 2 times the probability of big A, which we know is 0.4, times the probability of little a, which is 0.6. So here we get 2 times 0.24, which equals 0.48, which equals 48%. Now finally, we can ask, what is the probability of the AA genotype? And that's just the probability of getting a small a times the probability of getting a small a. So we have 0.6 times 0.6, which is equal to 0.36, or 36%. Now these probabilities are also considered the genotype frequencies in the population. So what do you notice about these probabilities? Well, the first thing you might notice is that the frequency, probability, of getting big A plus the frequency of probability of little a is 0.4 plus 0.6, which equals 1. So if we substitute the letter P for the frequency of big A and the letter Q for the frequency of little a, then we can see that P plus Q equals 1. And the probability of big A plus the probability of big A plus the probability of little a, which is the same as saying the frequency of big A plus the frequency of little a, big A, plus the frequency of small a, is 0.16 plus 0.48 plus 0.36, which equals 1. If we substitute our P and our Q in, we can see that P squared, which is this value here, plus 2PQ, remember we had to multiply our frequency times 2 because there's 2 ways to get the heterozygote, plus Q squared equals 1. So these are the Hardy-Weinberg equilibrium equations that you will need to know, is that the allele frequency P plus the allele frequency Q is equal to 1. And P squared plus 2PQ plus Q squared, which represent the genotype frequencies, also equal 1.